Okay, well, good morning, everyone, and welcome back to the International AI Cooperation and Governance Forum 2024. My name is Jason, Senior Research Manager at Concordia AI, and we will be exploring some critical questions in AI safety this morning. First, we will have a panel of stellar scientists who will shed light on scientific advancements and challenges for evaluating the safety of advanced AI systems. Second, we will have a panel representing viewpoints of regulators and third-party testing organizations to explain how industry and governments can cooperate on assessing AI risks. For the first panel, we will be joined by Professors Mohan Kankanhali, Li Bo, and Huangming Lie. Please proceed to the stage as I introduce you. Mohan Kankanhali is Provost Chair Professor of Computer Science at the National University of Singapore, where he is Director of the NUS AI Institute. He is also the Deputy Executive Chairman of AI Singapore, which is Singapore's national AI R&D program. Mohan is a member of the World Economic Forum's Global Future Council on the Future of AI and is a IEEE Fellow. Dr. Li Bo is an associate professor in the Department of Computer Science at the University of Illinois at Urbana-Champaign. She is a recipient of the IJCAI Computers and Thought Award, Alfred P. Sloan Research Fellowship, IEEE AI's 10 to Watch, NSF Career Award, and Best Paper Awards at several top machine learning and security conferences. Dr. Huangming Lie is a professor of Tsinghua University and deputy director of the Foundation Model Center of Tsinghua University, supported by the National Distinguished Young Scholar Project, and has won the Wu Wenjun Technical Advancement Award and Qian Weichang Technical Innovation Award. The moderator for this discussion is Ms. Wansi Lee, Director for Data-Driven Tech at Singapore's Infocom Media Authority. And in the area of AI, responsibilities include driving Singapore's approach to AI governance and collaborating with governments around the world around responsible AI. So put your hands together for our first panel for today.
Hi, good morning, everyone. I'm Wansi. Nice to see many of you here bright and early. And today, I think we're going to have a very interesting discussion, right, on the science of evaluations. We all know that the importance of evals in understanding models' capability, especially in the area of safety, in understanding and assessing the risks, right, that these pose. So today, I have three esteemed scientists in this space. And what I wanted to do is maybe get a bit, initially for the first part, get a little bit of understanding of the work that you're doing very quickly in this space. Introduce a little bit of what you're driving with regards to evals. Maybe you can start with Ming Lie and then we can go down this way. Yeah, thanks.
Wait, hello. So thanks for inviting me here. So what I'm doing is I'm leading a group of maybe 20 students, and we are working on safety and alignment and social intelligence. So specifically for safety and alignment, we are doing attack method. So try to make the system fail in safety issues. And also we try to defend this kind of various attacks, and we do detections. We try to detect which one's good and which is not good, and also we try to build a taxonomy and standards for safety issues. For example, just like Professor Tang Jie introduced yesterday, we are building benchmarks. For example, safety benchmark and the agent safety benchmark to evaluate the different kinds of safety issues. And the ultimate goal is try to build a reliable and a safe and trustworthy large language models and the multi-language models. That's what we're doing right now. Yeah.
Thank you. I'll ask you a little bit more about your benchmarks work later and your attack modules, for example. That might be interesting. But before that, Prof. Mohan, would you like to do a quick introduction?
Yeah. So my group has been looking into trustworthy AI, and over the last 1.5 years, we have looked at some of the really fundamental problems, both from a very empirical perspective as well as a theoretical perspective. To give you an example, we have looked into hallucination, and we have actually a theoretical result which shows that hallucinations is inevitable in large language models. And then we kind of moved on from hallucination in large language models to more empirical work on looking at hallucination in vision language models. And because that is actually slightly more complicated, because the inputs could be, a visual or text or a combination thereof, and there is more degrees of freedom for hallucination. So we are trying to characterize the hallucination in vision language models. We have been also looking into value alignment, like what you mentioned, and looking at basically, how do we make these systems more robust? So we're looking at jailbreaking and techniques for jailbreaking. But again, we are also trying to look at very fundamentally from first principles. And we've been looking into preference models, because we use indirectly preference models for doing the value alignment. And are there some problems with the preference models themselves? And of course, we are trying to do some empirical work on how do you use this human preference data for doing, bringing in all these values inside our models, and are there any vulnerabilities out there? So that has been more or less the thrust of my work over the last year.
Thanks, Mohan. Very interesting. Looking at robustness, hallucination, and then value alignment as well, right? Yeah. And then, of course, Boy, you've been doing a lot of work in this space. Maybe you'd like to do a quick introduction as well. Yeah.
Yeah, thank you so much. So our group, both research group and industry group, I'm also running a startup currently on AI safety security. And mainly we have three components from the methodology perspective. One is the red teaming, basically how to attack it, how to do the penetration testing for different AI models, systems, or agentic systems. And second level is guardrail level detection, so that we will flag out all the unsafe, risky content, no matter it's multi-modal, multilingual, or different like action level of unsafe or insecure content. And the third is mitigation. So basically, how can we do, as we mentioned, alignment, like improvement, but these types of improvement or alignment, we are trying to provide certain, like say, robustness or safety guarantees under certain conditions. For example, some conformal prediction risk categories or risk levels for different, say, agentic systems or in general generative models, so that we can have certain confidence about the safety level of different models. And these types of different methodology, the three components, usually can be applied to different scenarios, including like single model or end-to-end like ML ops systems and agentic systems, including multi-agent, so that you can view it as a game theoretical framework to provide different still like red teaming, risk assessment, guardrail detection, and mitigation with guarantees. Yeah, thank you.
Thank you. So all of you are doing slightly the same things and slightly different things as well. So that's really interesting, right? Where do you think are the limits of science today in evals? Where do you think the cutting edge is currently? Because I think from our perspective, we see a lot of benchmarking work being done, red teaming, adversarial attacks on models, jailbreaking, and so on. And starting also to see a lot more of these testing of agents, whether single agents, multi-agents, and so on. But where do you think are today in terms of science? We're at the cutting edge. Who would you like to start first? Perhaps Ming-Lie, yeah.
Okay, so I think for the moment, we are still at the very earliest stage of the model evaluation. So what we did today, what we are doing today is actually we try to build a static benchmarks, but it will be quickly fixed, or if you reveal some problem, for example, some kind of jailbreak types, this kind of issue can be very quickly fixed. So it will not work anymore to evaluate the real capability of the large language model anymore. So I think in the future we need to develop some dynamic and also maybe automatic method and algorithm to do all kinds of evaluations. So this is not limited to safety issues, but also to for example, to test the code generation mathematics, or reasoning capabilities. So, the central problem is just like the board talked about, red teaming and automatic attack and defense. Automatic attack method is very, very important. So what we are doing, right now is we try to build a red teaming method automatically, and then we are building open source project. The name is Open Attacker. So we try to simulate all kinds of attack methods. For example, role playing attack and the jailbreak attack and all kinds of attack methods to test, to see and to expose maybe this language model has some problems on this and on that. So I think this kind of research is very, very critical and very, very important. So that's what we should do in the next step.
Okay, yeah. Thanks for that. Boy, would you like to add to that?
Yeah, in terms of this field, I think there are a lot of things to do, like fundamental, like we are at the very, very surface now, yes, I think we all agree. And to me, I think there are mainly 5 principles in terms of like eval. And the first is, of course, the first principle, like what we should eval, right? Like basically what we developed so far, definitely not far from enough, is 2 principles. One is regulatory compliance, one is use case driven. And for both like lines of principles, we have developed like one is called AIR, like the regulatory compliance risks, which categorize to more than 300 categories and also integrated with Stanford Helm and have a comprehensive leaderboard. And in terms of use case driven, we have provided several like a decoding trust, which was also the best paper award at NeurIPS last year, and this year the best cybersecurity paper at National Security Academy. So this first level of principle, like what principle we should follow for the safety and the eval and understanding. And second level is under the principle, as we mentioned, what's the categories we should look into. Like for regulatory compliance risk, for example, then there are so many like EU AI Act, executive order. We like spend a lot of effort, map that to new categories, etc. But we can imagine there are new categories coming out. And what's the principle and the categories? We can call it, say, comprehensive, or we can call it like for certain areas or domains, it's comprehensive enough. So we don't know yet, and we can do our best. I think that's the second level, which is very important. And third level is we mentioned a lot about red teaming, and I would say it's the algorithm level. Like for each category, what's the algorithm that we need to, automatic generate, and to what extent we can find the long tail distribution of the corner cases, do the penetration testing, stress test enough. And the fifth is, of course, metrics, right? Now for Gen AI evaluation, we always use LM as a judge. And we all know that's biased and not enough, right? And for example, for code, we actually developed some more comprehensive like script so that we can quantitatively execute the code and evaluate the code. But for general NLP languages, it's still pretty hard. What types of metrics we can better or even ensemble to do this evaluation? And the fifth level is I would say it's threshold, but it's just more than a number as a threshold. It's basically the tolerance ratio that we consider on top of the metrics and algorithm we have, so that, for example, for medical domain and for like a customer service domain, their tolerance rate definitely is different. And how we can categorize this and put a metrics or constraint there so that we can provide proper corresponding evaluation for different domain. I think all these are unanswered yet, but I think it's very interesting to explore. Yeah.
Thanks. I think the point that you raised about there's a need to look at capabilities at the model level and what are the risks that the models introduce, and then at the use level as well. That would be interesting. And then finally, also then, how do we determine where the thresholds are? What do we find acceptable when it comes to after evaluation? Then we can talk a little bit about that later. But maybe just coming back to Mohan, where do you think, you've looked at hallucination and you talked about robustness. So what do you think are the other risks that we need to think about? And then where are we in terms of the science in addressing some of these other risks? Yeah.
Yeah, I think I completely agree with my colleagues. I think we are in a very early stage. And in fact, this whole area is dominated by empirical work. And we develop benchmarks, we develop tests, we do red teaming. And basically, as you said, there is some benchmark which comes out and the next year kind of it is part of the training data. Yeah. So I would characterize, if we say the science of safety in our area, I think we are like pretty much like what biology was 100 years ago, very empirical science. So here is this new beast called a large, foundation model, and we don't know anything how it works. So we poke the beast in different directions, see what kind of response it makes, and then we try to, say that maybe this is how it functions. And then we characterize it using, tests or benchmarks or whatever. But we have not really gone into the science of it. I mean, biology took 100 years to come up with the genetic basis of biology, and now the molecular, basis. So I think we need to proceed in that directions, that we need to come up with a fundamental understanding. And let me kind of give you an example, parallel examples in two other areas. I think security, computer security, actually also started off very empirically. Viruses came, and then you come up with patch, and but then later on, I think there is a very nice adversarial framework where you give some guarantees of any of the systems and their properties. And that took a while to develop. There is a great deal of empirical component in computer security, but there's a lot of well understood principles, especially coming from the cryptographic side and some of the system security side there. The other example I would give is in the area of control systems. Now, a classical control system, say, it could be an aircraft controller or any other type of controller in machinery. There we have mathematical models of the control system, and we know exactly what are the boundary conditions. Within these boundary conditions, the operation of this system is safe, and outside these boundary conditions, it is unsafe. And we know that we need to keep the system within these boundary conditions. So if there is a lot of turbulence in the aircraft, we know like what is the turbulence kind of which it can tolerate, and where you have to be alert about. Unfortunately, we don't know the boundary conditions of our models. We don't know the failure cases. We don't know the entire landscape of behavior. So even if you have a benchmarking data set, does it really cover the whole set of behaviors? There's no way of guaranteeing that. So I would like that at least some of us would focus more on the fundamental science, which uncovers the principles, like you said, behind it, and not just empirical level, methods. Because I think empirical gives insights, but the theoretical principles will give guarantees. Because ultimately, I think I completely agree with you. It is about risk management. We are going to have AI system deployed into larger systems, and we need to understand what is the uncertainty risk with this. And then there are certain areas where the risk is acceptable, or the acceptable risk could be higher, and therefore we deploy them. I think recommendation systems for general recommendation, I think the tolerance to risk is much higher. On the other hand, medical recommendation, the tolerance to risk will be much lower. And if we can quantify the risk, then where we know what to deploy, when and where.
Yeah, so actually that's a very good point. So first is prioritization of risk. I think that's the point that you were making. What risk do we care about, right? And then in dealing with assessment in evals, in testing is a way to quantify the risk, right? And in quantifying the risk and understanding what are we dealing with, then the next step really is then the mitigations, right? How then do we address the risk if we are concerned that they are not meeting our expectations, or if the output or the performance of the models are not meeting our safety expectations. So let's talk a little bit about, I'm quite interested to push a little bit more in the area of mitigations, right? So I know this panel is about evals, but I think a very logical question after this is, so what, right? So you've done evals, so what happens after? Maybe one of you would like to just briefly talk about what are some of the ideas that you have in regards to mitigation. This question came out yesterday as well. I was on the panel, and somebody from the audience asked, yeah, we've done an evaluation. We know how it's performing. I don't know what to do after that, right? After I get my results. If I'm not comfortable, what should I do? So maybe you can start with Bo, if you have some ideas. Yep.
Okay, yeah, I think that's a very good and important question. And the two things I want to mention. First is that especially for AI systems, I think the mitigation or risk mitigation is quite aligned with the red teaming and the attack eval perspective. Because I always give the example that in traditional, say, software systems, if you do penetration testing and the risk identification, you find the bug, you can easily fix the bug by looking at the human code manually. But for AI, even I tell you if the model is not safe, it will hallucinate, etc. There is no easy way for us even manually to fix it. Therefore, the process of generating those attacks, uncovering the corner cases, the long tail distributions of the abnormal behaviors of the model, etc., are very important for us to leverage for mitigating the risks. I think that's a high-level principle, and therefore, concretely, the way currently there are many algorithms for fixing different types of bugs. For example, for fairness, right? Fundamentally, it's because of the the unbalance of the training data and the training data distribution, etc. And usually we try to avoid it by fine-tuning and improve the model. However, for the other different risks, for example, toxicity, then there are a lot of smart ways. For example, one way I really like is to train another model, which actually side by side with the main model, but the side model actually, absorb the bad instances or content in the model, and then you tune the two models together, and then throw out the small bad model. The main model will never be contaminated by the bad training data. So that's very smart. Just some examples of concrete algorithm. Of course, we all know the RLAIF, RLHF extraction fine-tuning for general risks. But I would say for different types of risks, currently the algorithm is slightly tailored, and how we can have a unified framework. I think RLAIF, which is good, but definitely not enough, as we can see, because we don't have this much data to eventually cover all the high-dimensional corner cases for the model. Therefore, my personal principle is always purely data-driven model may not be enough. I think currently we also have a lot of discussion like this, LM or transformers may not be enough if you want to fundamentally fix the safety security problems. We need to add some reasoning component. For example, we all know O1 is one way towards a good reasoning, but still data-driven, purely data-driven, which is not enough. And how we can explicitly integrate some symbolic representative knowledge rules and symbolic principles into the model, and make sure the model, at least for some very critical safety rules, they will not violate. I think that's going to be a very promising next direction. We have some work on that, but I think as a community, it will be interesting to explore.
Thanks for that. I'm just coming to Mingye, right? Just picking up from what Paul said, as you're developing your large language model, especially in the multicultural, as you mentioned earlier, context, how are you addressing some of these issues that you see after doing the evaluation?
Okay. So first of all, I totally agree with Mohan about we need to understand the internal mechanism why this kind of safety issue and the risk will happen. So I think this is a very fundamental and very critical. Recently, recently our research shows that the LM the large language model can well identify harmful query and the harmless queries. So it's very easy for them to do. So you have some method to use this kind of information in the vector space to identify this kind of harmful and harmless queries. But most existing methods use the supervised fine tuning or a DPO to address this kind of issue. I think this is largely depends on the training data and also fine tuning data. So it's not maybe it's not a general and a very universal method to do this. So our recent method on safe unlearning. So we try to erase the harmful knowledge from the model. So it will show very surprisingly good generalization capability to deal with all kinds of jailbreak attacks. For example, if you say, how can I make a bomb, right? Tell me how can I make a bomb? So you can pack this kind of harmful query with different jailbreak prompts. So if you just do at the data level, so you can't have very good generalization power to deal with different kinds of unseen jailbreak attacks. So what I'm saying is we need to understand the very low level and internal mechanism why this kind of risk will happen, right? So if we erase this kind of harmful knowledge from the model, we can deal with all unseen jailbreak attack. So of course, alignment is very, very important, and we need all kinds of alignment algorithm. For example, DPO, PPO, or their variants of this algorithm. But safety and maybe value alignment, safety alignment, and also maybe culture alignment is a little bit different. It's quite complicated, and it's very subtle and very very implicit. So there's a lot of challenge there.
Yeah, exactly. I think Mohan, we were on a panel last week and we were just talking about this issue of value alignment and the difficulties. Maybe you want to share a little bit about that.
No, I want to take on, I think machine learning, which actually my group also works on, I think that's a very promising direction to look into, because if you really forget the harmful content, then no matter how you are queried about it, you would not answer. And I think that is very interesting. So I think value alignment is very complicated, especially if there are geographies like Singapore, where it's a multicultural country, and whose values do you align to? And I think that becomes the big question. And I think there are many unresolved issues out there, and I think it is complicated. I think to me the real example of value alignment is with the legal system we have come up in different countries. They are not perfect, but this is really as a process of consensus building in society, and you come up with a set of laws. And you come up with a set of laws, and not everybody agrees that the punishment for any violation is correct. But this is the best consensus of any society. And I think likewise, I would say that the value alignment in large language models will also reflect such a consensus of the society where it is deployed in. And I doubt it will be perfect at any point in time. And it is going to be always work in progress in how we do that. So I think Bo has mentioned, and you have mentioned a lot of these mitigation strategies. To me, I think given the current really dominance of AI in all conversations, we should not forget, and I'm speaking as the former dean of the School of Computing, there are a lot of other disciplines in computing which have not just vanished because of AI. And the reason why I highlight is I think we use these foundation models for what they're good at. But if you're going to build a real practical application system, it can consist of components or agents of other areas. And just to give you a very naive example, if you have in whatever application you are doing, you have to do some calculations, right? Now, we have built calculators for decades now. If you type on a calculator 3 times 4, we can verify the output. But if you multiply a large digit by a large digit and you see the output on a calculator, you pretty much trust it, because this algorithm has been verified, and if it goes beyond the range, it will give an error, okay? So why would you use an LLM as a calculator ever? I mean, it is nice as an intellectual exercise to see the capability of that. But when we have a known working algorithm with precise properties, then if I have to use calculator in any of my application, I would actually invoke an external calculator program, use its input, and then process it with my foundation model. So I think this whole notion of building applications as a composition of many components or agents, and some of these agents don't have to be AI agents, and they can be very reliable, trustworthy, where we know the properties. And then, of course, the real intellectual challenge is, how do you put together these components? Some of that are trustworthy, some of them are perhaps less trustworthy, and overall, as a system, can you give some guarantees of that overall level of trust? And I think this is going to be the big intellectual challenge in this area.
It's also a capability challenge that we have to introduce into the ecosystem, which I think Shamik, who's here, he's following my panel after this, and he's going to talk a little bit about this as well. How do we deal with use, right, in sectors, in the enterprises? And this is really about pulling different components together into applications. So we have a little bit of time left. I'm just going to talk, maybe segue to one more question about how we can work together, right? A lot of these evals capabilities are in the big AI labs, right, in enterprises, especially the model developers. A lot of these evals capabilities are also in academia, in research institutions. We're starting to see governments also needing to build this capacity within the institutions, within government agencies as well, because they also need to test and understand before they can even think about regulating. So a couple of weeks ago, I was at the AI Safety Institute convening in San Francisco. So I co-lead the track on evaluations together with a colleague from Japan. And a lot of the conversations that we have with the other ACs are around how do we develop the science and methodology of evaluations, right? So coming from academia, and I think, boy, you're also in industry, having a startup, what do you think, we need to do together, right? How do we support governments and how do we support the ecosystem in building up this capacity in evaluations? Well, starting with Paul.
Okay. Yeah, I think that's a very good question. And I've also been thinking about it over our collaborations in terms of what we can contribute from academia and also from industry, and also what we can ask for from our industry and government partners to see how we can benefit and in charge of each other. I think there are two levels. One is we can separate the work because we all have something we're good at. For example, from academia-wise, we can focus on the methodology and the fundamental methodology, like Mohan said. And then from the industry and the government level, people have very rich scenarios and application, different levels of metrics, requirement, etc., which can provide so that we can go hand by hand and provide, say, fundamental algorithms which can be adapted to different, say, applications, requirement, etc. And this can be a kind of reinforcement loop. So we have feedback and then we continue to improve, so that I think these types of collaboration will be very helpful, which is horizontal. And of course, we can have vertical wise as well, like everyone work on the fundamental algorithm and the scenario a little bit, because, for example, for agentic systems, although it's a very hot topic, but we don't have a lot of real-world scenario yet. So we do need academia start from the, creative perspective to think what it will be the future scenarios, and then create some simulations and imaginary scenario, and provide evaluation and provide analysis, and then industry will take it as say, oh, if on this scenario, whether it's aligned with my actual practical, constraints and problems, platforms, etc., and then do a little bit massage and polish. So I think these vertical and horizontal collaborations will be very helpful.
Thanks. How about Ming-Lie, coming from Tsinghua, how do you think we could internationally collaborate on evals?
Yeah, I think this is a very, very interesting question. So, in the yesterday dinner, so we talk about with Professor Crystal, right, from Geneva here? No, maybe he left. Okay, so if you tap the same ethical question to different models, for example, ChatGPT, Claude, and Llama, and the GLM by Tsinghua, and also maybe Mistral, so you may get quite different answers, even for the same ethical question. So if you ask whether Taiwan is Taiwan part of China, right? So you got a quite different question. So I think build a international cooperation organization to deal with this kind of safety or sensitive questions, I think it's very, very important. And this is one aspect. Another one is, for every country, we have different safety issues and concerns, right? For Singapore and for Indonesia and for China and for American, we have quite different safety and the ethical issues. So because of the politics and because of the country itself, right? So how can we respect this kind of individual features, and also how can we share the common, common concerns all of the world, around the world, right? So I think it's very important to establish the international cooperation for this kind of safety and ethical concerns. And today, what we are doing is actually we build benchmarks. But for example, in Safety Bench, developed by my team, so we also have a bilingual corpus for that. But maybe we have a conflict with the the benchmark developed by the American researchers, for example, BBQ or some other benchmarks, right? So I think how to get this kind of agreement is very important for. That's why we need international cooperation for this kind of issue, and also to test the different large language models. Also, I think it's also very important to see. Okay, this we should have some. We have some agreement on the answer, but we don't need to have this kind of agreement. So that's my thought.
Thanks. I think from my own experience, it's number one, hard to agree on what to test internationally, and then two, hard to agree on the answers on what we accept. But that's very interesting points. Mohan, do you have anything else to add to this in terms of cooperation?
Yeah, I think they pretty much covered everything. I think cooperation is absolutely necessary, and one of the things which we find in academia is resources. Some of the resources are lacking, and therefore cooperating with industry and larger organizations is very critical for us, because a lot of the ideas we have cannot be tested unless we have the resources. So I think that is very important. Let me have a slightly different take on the safety issue. I think there are two fundamental levels of safety. One is use of this AI system and misuse it. So, when we do a misuse, and there is a deliberate misuse or an inadvertent misuse, so there is a misuse of these systems, and there is a safety issue related to that. And that can be tackled not just by, alignment and all that, but there could be some regulatory kind of inputs for that. The second type is the actual model's intrinsic behavior, how safe or unsafe it is. And this also is related to value alignment, but sometimes it can be more to it. To me, I think, given all the challenges which we have discussed so far, I think there is a real emerging challenge in the science of safety, is once we have what you mentioned as agentic systems, and when the agents have an ability to control physical systems, like cyber physical systems, I think that is going to add another new vector surface of attacks. And the second thing is that once you have parts of a multi-agent system which can write code, and that gives a tremendous amount of flexibility in what that code can do. And I think we are kind of venturing into somewhat uncharted territories where our AI system, maybe agentic systems, will control some physical actions in the real world, or produce code which can go ahead and have some other type of behavior. I think if we thought that all the work we are doing is challenging, I think there is going to be another level of challenge coming up with that. Yeah,
it's and it's also hard to test, right? I mean, today you can test in a very specific context, right. But when it comes to agents, if they are able to operate, you actually do need to be able to test in sandboxes, right, in certain real world contexts, so that you can then understand how they'll behave. So that's also another layer of complexity when we think about evaluations when it comes to agents. I'm going to end soon, but maybe just one last question and a very short answer from all of you. We're already at the end of 2024, December. So many things have happened this year already. It's been pretty crazy, this and last year. So looking forward to 2025, what is the one thing that you hope to see happen in the eval space? Just one sentence for each of you, starting with Ming Li, and then Mohan, and then finally Po. Yeah.
Okay. So I just maybe elicit more open source project on the safety and risk issues. So what we are recently doing is we try to build an open attacker, so to simulate all kinds of safety attack. So it can maybe do jailbreak simulation and misinformation and disinformation simulation. So I think that will promote the research of this kind of research very significantly. So we need to do some more open source. Yeah.
Thank you. Pohan.
I think I will reiterate my point. I think we are like what biology was 100 years ago. So I think we need a whole bunch of people doing empirical evaluation, empirical testing, empirical mitigation, but we also need sufficient number of people to look into the fundamental principles and come up and with these principles, which will then guide the empirical investigations. And this can be a nice synergistic kind of a cooperation. I hope to see more of that.
Agree. Paul?
Yeah, totally agree with that. And the one concrete thing about this fundamental thing I would like to see is maybe some standards for at least certain domains for the safety security so that we can follow. And just as the example you mentioned about like a biology. So in the end of the day, we have, say, this genetic project and we can align like what's in charge of what types of behavior and phenom, etc. And hopefully we can still also have such mapping for AI safety security and get it at least for certain domains and safety critical domains at least to be aligned. For example, for the code you just mentioned, actually I want to mention one interesting observation that we actually recently attacked all the Codium, cursor, everything you name it, you used recently, but they are so insecure and can output all the types of malwares you can imagine with very stealthy prompt. We just cannot publish that yet because it's so dangerous. But like if with some standards like a regulate or some standard common agreement on this, these types of things or discussion will be much easier.
Thank you. So with that, I'd like to invite all of you to give a warm round of applause to our three panelists. Thank you so much for your very insightful observations.